5. We didn't actually finish in 5. 5, 6, what we call rational zeros. And we have what's called, first off, a rational zero theorem. By the word, rational zeros means real fractional zeros. But even when you use the word fraction, it doesn't necessarily mean it's a fraction. 2 is considered to be a rational number because it can be written as a fraction, 2 over 1. Okay, so this is real fractional zeros. And we have what's called the rational zero theorem. It's probably easier than it's written out up here. I'm assuming it is. Yeah. The polynomial f of x, every rational zero, has the following form: p over q, where p is the factors of c. When I say c, I'm talking about the constant. Over the factors of a. Now, where do you find a? This is the first coefficient. Now this says that little list gives you a list of all possible potential zeros or roots. There's an example up there that I kind of worked out ahead of time. So I can talk about it before we do one. Usually the EOC has a question like this. It'll be multiple choice. It'll say, which one of the following choices might give you the possible zeros of a function? And all you're supposed to do is find the factors of C and put over the factors of A. Missed by a lot of kids. Because y'all just don't want to do algebra 2. What it boils down to. Anyways, I have the example up there. The example is 3x squared minus 10x minus 8. Where p is 8, because that's the factors of c, and q is 3, a. Has the potential zeros of plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. See right there that plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8? That came from the factors of 8. Sitting over plus or minus 1 and plus or minus 3. That came from the factors of 3. That's a list of potential zeros. Now, when you do the math here, you do 1 divided by 1 is 1, 2 divided by 1 is 2, 4 divided by 1 is 4, 8 divided by 1 is 8. And then you divide everything by the 3. So if this thing has zeros, fractional zeros, it's in that list. That's all this theorem says. If it has a rational zero, it's in that list. Or fractional zero, it's in that list. So our first example is to probably find all possible zeros of this function. Now here's your setup. You take factors of C over factors of A. Well, I'll just start off with my constant. What is my constant? Nope. 9. What's A? 25. So my potential zeros are factors of 9 or factors of 25. That's my potential zeros. Then I just got to break it down. What are the factors of 9? 9, 1, 3, and 3. So what I would do is I'd start off by saying plus or minus 1, plus or minus 3, plus or minus 9. Now, the reason I do plus or minus is because I can have a negative times negative and get back to a positive 9, right? So it's either positive or it's negative. Over in factors of 25. What's your list for factors of 25?
1, 5, and 1, 5, and 5.
1, 5, and 25. Plus or minus 1, plus or minus 5, and plus or minus 25. There's my list. I just got to do the math here. First thing I'll do is I'll divide each of the top 3 pieces by 1. Plus or minus 1, plus or minus 3, plus or minus 9. The next thing I'll do is I'll take each of my top pieces and divide them by 5. And I'm not going to go to a calculator and do this, kids. Just write it as a fraction. 1 over 5 is a fifth. 3 over 5 is 3/5. 9 over 5 is 9/5. The last thing I'll do is I'll divide everything by 25. So if that thing has a rational 0, it's in that list. It's a really simple theorem. For that question, as that one says, or is it? Now, this doesn't actually want you to find all the zeros of that thing, but we're not going to do it with this example. That says find all possible. It doesn't actually say find. It says find all the possibilities. No, we're done. That says find all possibilities. It doesn't say find them. The next one, however, is going to require some more work. Find the zeros. We're going to find them. It doesn't say list possibilities. It says find all real zeros of x cubed minus 4x squared minus 15x plus 8. We're going to list the possibilities. Possible zeros are factors of c over factors of a. So c is 18. I'm going to do this in 2 steps instead of 1. You got c over a. It's 18 sitting over 1. Because a is 1. In front of x cubed, there is a 1. This is actually a pretty short list. All we got to do is write down the factors of 18. What are the factors of 18?
1 and 2.
Plus or minus 1, plus or minus 2, plus or minus 3. You guys forgot about 6. Plus or minus 6, plus or minus 9, plus or minus 18. And it says do this using synthetic division. We're going to do a lot of guessing. What we're going to do is we're going to guess a 0. Now, if I guess a 0, say I guess pick 2, and I do synthetic division, I get a 0, what's that tell me? It tells me 2 is a 0. Okay. Say I pick on 3. 3 has a remainder of 9. Is 3 a 0? No. No. I'm looking for zeros to do this. And this is how I learned this stuff. And it's why I still remember doing it, because it was a huge pain in the rear. But I did it. So I remember how to do it. So somebody make a guess. There's your list of potential zeros. Pick one. All right. You guess a 0. Do you want positive 6 or negative 6? All right. Positive 6 was guessed. We're going to do synthetic division. Where do you put that positive 6? On the outside. What do you load the top of this thing with?
1, negative 4,
Coefficients, which are 1, negative 4, negative 15, and 18. And what do we do with that 1?
down.
Now, there were a lot of you guys on that basics quiz who could not do synthetic division. After you drop that one, what do?
Multiply.
Multiply. 1 times 6 is 6. And it goes right here. I don't know if I should be using multiple colors or what I should be doing, but something needs to be done. What do you do with negative 4 and 6? Add them.
So you have positive 2.
And positive 2. And after you add, you get 12.
Negative
3. 3.
3. Negative 2.
Boy, you got lucky.
Yeah.
You found it on the first try.
Oh, yes.
You got lucky. Now, that was 1, 0. How many are there?
3.
There's 3. It's x cubed. But let's think about what we wrote. There was a little message off the side. I moved off the board. What did it say?
We can either factor or
Get it down to a quadratic. You pulled an x from x cubed. What's left? You have a quadratic in front of you. This last piece is your remainder. Proceeding the remainder is a constant. Proceeding a constant is an x, and proceeding an x is an x squared. What you did is you reduced this thing down to x squared plus 2x minus 3. And there should be how many zeros still there? 2. So say it equals 0 and figure out how you might want to solve it. You might factor. You might be able to do the quadratic formula. Factor that one. That one factors. What's the thing creating x squared? Your factors of 3. 1 and 3. You want to get to a positive 2, so which one's positive and which one's negative?
3 is positive.
3 is positive, 1 is negative. So if x minus 1 is equal to 0, what's x?
X equals 1.
X equals 1. If x plus 3 is 0, what is x?
Negative 3.
There you go, you got your 3 zeros. Sam lucked out, guessed one on the first try. Usually this thing takes about 5 or 6 more rounds. And then we factored. We couldn't factor this quadratic formula. So there's one example of this. Here's another one. All right, right off the bat, it has 4 zeros. It's good. How'd you know that? X to the 4th tells you that. So we're going to have to guess 2. And then factor or quadratic formula. Okay? First thing we'll do is we'll list the potential zeros. What we're going to do is factors of C over factors of A. So factors of, what's C? 42 divided by factors of 2. I write these things out in order. That's me. Get to 42, you need a 1 or a 2. See that thing? It does. 6 does. 6 times 7 is 42. Let's see, the 3 I used is 14. I missed one. 3 times 14 is 42. 2 times 21 is 42. And lastly, we have the 1 and the 42. That should be all the factors of 42. And you guys are young, your list probably won't be in order. The bottom's easy. Factors of 2, plus or minus 1 or plus or minus 2. If we go through and do the reduction, it's going to be a long list. It is. We're going to have a plus or minus. We're going to divide everything by the 1 first. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 7, plus or minus 14, plus or minus 21, and plus or minus 42. The second half of this list won't be that long, because some of those things repeat. There's no point writing it twice.
Yeah, we'll have.
Half that's new. The 1/2 comes from 1 divided by 2. 2 divided by 2 is 1, so that's already there. 3/2 is new. 6 over 2 is 3, that's listed. 7/2 is new. 14 over 2 is 7, that's already in there. 21 over 2 is new. And 42 over 2 is 21. So this is what you get to pick from. We have to make 2 good guesses out of that list. We'll go with 14 off the bat. Hit you again, Sam?
I'm feeling like.
If you get this right, I'm going to take you up to Q-Mart and we're going to buy a Powerball ticket. I'm not kidding. I will come get you out of your next class. And we will go to Q-Mart and we will get a Powerball ticket. You can't buy it, but I can. I'm just gonna let you pick the numbers.
Yeah, he will.
You want positive 14 or negative 14?
Trace the positive.
No, this is all you.
It's all you.
All you.
Negative.
Negative.
We're going positive here, so let's be.
All right, so you pick negative 14. That goes on the outside, coefficients up top. Now, if he's right, our remainder is going to be a what? 0. What do we do with that 2?
Bring it down.
Bring it down. All the way down. That's going to be negative 28 when you multiply together. Negative 23 when you add. And stop it.
Totally got it.
Why am I stopping?
Because yeah, negative 23.
What's 14 times 23?
It's bigger than
What's way
42.
bigger?
It's way bigger. I guess we need to work through this out because some of y'all aren't seeing why we want to stop. The numbers are going to get huge.
Hey, I thought you were going to get part.
Yeah, I know.
So if you did a positive, you can get. It's just what, 7? What? Positive.
That's 322. So that's 304. That's negative 4,508.
Good job, man.
Negative 4,527.
I see you
63,378. Anyways,
so close there.
yeah, it's too big.
Definitely
You
more
weren't
than
off
6.
by far, Sam.
Positive 3 is different.
Yeah, it's only off like 6.
So, Sam was wrong.
Almost a positive.
Yeah, just a number or 2 off.
Almost a positive. Definitely positive.
Start over.
6. 3.
Let's go with Trey's suggestion of 3. Smaller is usually better. Usually. Trey wanted 3. I just erased what I had. Start over, kids. You can do this on a new line. I just hung up the board. I just erased it. 3 times 2 is 6. 5 plus 6 is 11. That's a 33. Negative 18 and 33 makes 15. 3 15s is 45. Negative 19 and 45 is 26. And 3 times 26 is 16 and 18, 78. Not a 0. 120.
Cross out 3.
Maybe not. Don't cross out all of it.
Oh, yeah, it could be negative.
You can try the negative 3. Why not?
Let's get right to it.
Negative 3 times 2 is negative 6. 5 minus 6 is negative 1. Negative 3 times negative 1 is 3. Negative 18 plus 3 is negative 15. Negative 3 times a to 15 is 45. Let's see here. That's going to be what, 26. That's negative 78. Negative 3 doesn't work at all, does it? I think girls know. Any other suggestions?
-2.
-2.
Guess you're right. That was smaller.
Well, the smaller numbers are generally the ones you want to pick. Now, the problem is things are getting too big. So Christina made a suggestion for a -2. We just repeat the process again. We drop, then we multiply, then we add, then we multiply, then we add, then we multiply, then we add, then we multiply. Good job. Christina, you found
Good
one.
job.
She found 1. How many do we have to guess, though? Okay. Now, we're going to reuse that line right there. The goal is to reduce this down to a quadratic. This line has us down to a cube. We're going to reuse that line. I'm not even going to write it down. Don't care. Really don't. That's where I'm going to start doing some division. Right here. Just like I did before you left the break. Right there. Need to guess one more 0.
One half. 7.5. I say.
We'll go with 1/2. I'm not going. I don't think 1/2's going to do it.
I don't think you do
6.
that.
6.
Say the same.
6 times 2 is 12. That makes 14. No, Christina.
Hold on, what?
Yeah.
6 wasn't a good one.
Yeah, 14.
7/2.
3 over 20.
7/2.
How would you do so?
Well, you do.
You drop, you multiply, and you add. What's 7/2 times 2?
14.
Over 2.
Oh, so it's 7.
It's not gonna work anyway.
I thought you said 7. Good try.
1 plus 7 makes 8. What's 8 times 7? Divided by 2.
28.
28. Negative 20 and 28 makes 8. 8 times 7 is 56. Divided by 2 is 28 again. It wasn't that far off.
So it could be 3/2.
I'll try 3/2. Don't forget, you guys are thinking about your negativity as well. Off to 2. What's 3/2 times 2?
6.
3.
3. You add. What's 3/2 times 4? 6. And you add. 3/2 times negative 14. Okay, what's 14
Negative
divided?
21.
What's 14 divided by 2?
So
Times the negative 3. 21. Hey, you found it. Now let's think about what's left. That 0 represents the remainder, constant, x squared. The goal was to get to a quadratic. That is our goal. So we have 2x squared, plus 4x minus 14. That's where the other 2 zeros are, so you say it equals a 0. And then you either attempt to factor or you hit it with quadratic formula. I would attempt to factor this thing. I don't know if it does or not. But either way, I can make my life easier. All 3 terms have one in common. 2. My first commandment. I don't think it factors. But it does make the quadratic formula easier to do that. There are no factors of a -7 that'll add up to 2, are there? No, so I'm gonna hit it with quadratic formula. I know this is long and tedious. If it is, and you think you're going to college, just throw that dream away, kids. Like if this is too much for you and you know you want to go to college, it's time for plan B. I don't mean that to be mean, but you're not going to make it. That's the honest truth of things. You know, they told you when you were a little kid, you can be whatever you want to be, and they were not lying to you. Nobody was lying to you about that stuff. You just thought that meant you didn't have to do anything. You're like all these stupid kids complaining, or all these young people complaining about this stimulus money. If you need the government to give you money, you got a problem. That's a problem you created. I'm not gonna lie, I done spent it. I went and bought a new couch. I knew it was coming. But did I need it? No. No. Didn't need it. I ain't gonna say no to it. But I ain't gonna complain about it. It's free money. It's actually not free money, but. Anyways, let's do the quadratic formula here. What's A?
2.
A is 1. What's B?
2.
Let's C.
7.
I'm using the smaller numbers. So X would be opposite B, -2, plus or minus square root, 2 squared, minus 4, all sitting over twice a what? 1. A is 1. Just quadratic formula. 9th grade math exams. You got. That's 2 squared. Inside that radical should be a 30. No, 32. 4 sevens is 28. I do a little math in there, that's what I've got. I did say find all the real zeros. Is that thing real? Yes, it's just ugly, right? If it wasn't real, I'd see what in that radical? A negative. Okay. I would see a minus 32 or something like that. That thing simplifies. 32 is 16 times 2. What's root of 16? 4.
So your other two races probably more than equal.
No, we're going to simplify the radical. Root of 32 is 16 times 2. And that 16 was 4. Still got to simplify. 2, 4, 2 down low, all goes up by 2. I ran way out of room here. I got -2 over 2, which is -1. 4 over 2, which is 2. Here's your last 2. They're ugly, but they're real. So it turns out your zeros were at -2, 3/2, and then -1 plus or minus 2 root 2. Now, on your homework, you have to show me the list of potential zeros. I am not going to be Miss Buckley to you like she was to me. Miss Buckley, she taught me this stuff. You'd be far better if you would have had her in 8th grade than whoever you had. No offense to whoever you had in 8th grade. You may have loved that person, but had you had Miss Buckley, you'd be much better at math. She teaches 8th grade now. I mean, no offense to whoever taught you 8th grade math. I really don't. But Miss Buckley's one of the best teachers there is in the county. Anyways, what I'm doing here is I'm going to graph the original function. There's a reason I'm doing that. Seems like the original question was asking you to find all the real zeros, right? Grant, you want to do this? So I throw the equation in y1, and since I want to know where the zeros are, what do I throw into y2? Throw 0. Good job keeping up. Like I said, here's what I said. I said, you don't have to do all this work on your homework, and I'm going to do something a little easier with y'all, and you just kind of sat around with your thumbs up your rear end. 40% of my algebra 2 kids are failing. I have never in my life seen such a disaster. It's all because you like playing with your butthole with your thumbs up the darn things. Little funny, don't know what sex you are kids. So I threw the equation to y1. I threw a 0 into y2. And I'm just going to do a standard zoom 6. Zeros happen when you cross what axis? X. There's 4 of them. Now you can probably guess, if you look kind of pay attention, as to what some of these are. What was our list originally? -2 and 3/2. There's the -2, and that one's pretty clear. You know, you can pull out the easy ones by doing something called looking at the table. You'll see table over there in blue. If you hit the second graph, it'll pull up the table. If you'll scroll to where x is -2, what's it say the y value is? 0. Your table doesn't do fractions, so you're not going to see that other one of 3/2. I hit second table, and I kind of
So the
scroll.
one that I mentioned, is that 2 of them that hits the dash?
Let me get there. I'll just answer another question. If you go to the table, you'll have an x value and a y value. You're finding a 0, so you're looking for a y is 0. That happens at -2. I would have let you look at a table and found that one instead of guessing. Or you could have looked at the graph and said, I'm pretty confident in that thing. You know, there's also a reason I put a 0 into y2, because now I can use the intersect feature. I can do second trace, 5 for intersect. And I can find at least the decimal equivalent of all these things. I'm going to hold my cursor all the way to the end. Get it right there. And then I'm going to press enter how many times? Enter, enter, enter. Now you get some funky looking decimal. Is that something you'd want to do synthetic division with? No. That's one of those weird answers. That -1 plus or minus 2√2, which by the way, you have to write it like that. I will not accept a rounded decimal for that. I want the radical. I want the radical. I do not want the decimal. So that's not something I would do synthetic division with. Well, go after the one to its right. Get my cursor in the neighborhood. Enter 3 times. That's something I would do synthetic division with. In fact, we did synthetic division with it. And that's kind of it for your notes. But what I'm trying to show you is use your calculator to make the guesses, kids. Some of you guys get that, some of you don't. Your calculator can give you your guesses to pull out, so that you can find the weird ones with the quadratic formula. And that's it. We only had one more left, didn't we?